This is a model which shows the basic design of such a vehicle. It consists of a chemical first stage and of a nuclear upper stage. Let me show you some pictures that might be of interest. The vehicle takes off vertically like a chemical rocket. You can see this on that picture over here. The overall size of the vehicle is 200 feet tall and 20 feet in diameter. And it has a gross weight at takeoff of 1,800,000 pounds. That's about 4 to 5 large bombers.
It's about the size of a 20-story building almost.
That is almost the size of a 20-story building. Now the vehicle ascends like a normal rocket and then tilts over and delivers eventually, the booster delivers eventually the upper stage at an altitude of about 150,000 feet. Then the propellant supply of this stage is exhausted. And it is released now from the upper stage. It separates, it breaks away, and becomes, as you can see here, a blunt-nosed airplane. As such, it glides down back to the surface of the Earth. Now you have the vehicle in the process for spaceflight. The crew itself sits in the rear end here in a container, in a torus-type gondola, which is wrapped around the nuclear pile and the expansion nozzle of the nuclear engine. We can therefore not ignite the nuclear pile before we have not removed the crew from the vicinity of the pile for safety reasons, radiation protection. Now this is in this particular case done by design which provides a separation of this gondola from the main vehicle in the fashion as it is shown here. This separation is done by means of reverse thrust. The cables are tungsten cables which can sustain a considerable heat. Now, after the little counter-rocket engines have pushed this to a distance of about 1,000 feet from the pile is being ignited, started by remote control. The vehicle is now continuing its flight into space, pulling the gondola behind it. The crew is absolutely safe because it is at a sufficient distance from the power plant itself. Now you can go on with your propulsion in this fashion until you have reached the proper velocity that you want to have in order to fly to Mars or to Venus or over to the moon. The vehicle coming from the surface of the Earth approaches the moon, slows down to a vertical descent, and then sets the gondola down first in a non-contaminated area, very gradually. And then by remote control is directed sideways and downwards and lands in a separate area about 1,000 feet away so that there's a minimum interaction, or in fact no interaction at all, by radiation or radioactive dust that is in this general area here that might bother or endanger the crew.
How far off do you think it would be if we had a go-ahead for this program?
I believe we could have a vehicle of the Helios class in the second half of the next decade.